G'day guys, today we're at a beautiful kitchen for one of our customers and we're changing some downlights above the bench top here to some hanging pendant lights. The pendant lights we're putting up today have been selected by the customer. Ideally, when you're replacing feature lights or unique lights for customers, it is best to get them to supply them. When locating these on the ceiling where downlights have previously been, there are a couple of considerations to make before the customer purchases these lights. The first consideration to make is to ensure that the base that mounts up to the ceiling is large enough that it's going to cover the existing downlight hole. In this instance, we're going to be removing these old 12-volt halogen lamps from the ceiling, including the transformer. When working out the complete size of the light fitting, it's easy just to take the measurement from either side of the stainless steel and ensure that the base is going to cover that. If you need to work with smaller dimensions, by all means you can remove the light fitting and measure the size of the cutout hole, providing there's no blemishes from the existing stainless fitting on the ceiling. Then potentially your fitting could almost sit inside that circle there. In this case, if we're going from the outside of the fitting, the diameter is around 94 millimeters. And so we can see 94 millimeters is easily going to fit inside the pendant base. The second consideration you want to make is if the fitting's supplied by a customer, given that they can parallel import things online, we need to ensure that it's compliant in New Zealand. Always look for the regulatory compliance mark, and it will be a tick inside a triangle. This mark shows that it is fit for purpose and safe to use in New Zealand, and the standard it's controlled by is ASNZS 4417. Generally, pendant lights are not supplied with their own lamps, so it pays to ensure that if your customer is supplying the light fittings themselves, that they purchase the lamps separately. Most of the time, a salesperson will ensure the customer doesn't buy the fitting without a lamp. The next step, we're going to be removing these downlights. Before touching anything that is connected to the electrical installation, you must isolate it. What we're going to do is turn the lights on. As you can see, only 2 of them are working. Now we have to work reasonably fast with this because as these lights are halogen, they tend to heat up very quickly. At the switchboard here, we can identify easily which circuits are dedicated for lighting circuits, and we can isolate these one by one and check exactly what one isolates the kitchen circuit. We'll try that one first. After ensuring that the light switch is non-operational for the lights, we know that this circuit is now isolated at the switchboard. Now this is only one of 2 steps that we're going to do to ensure that light fittings are isolated. The second step I'll show you once we start removing the light fittings. Every electrician and electrical apprentice should have access to a lockout tagout kit. If you don't already have access to a lockout tagout kit or system in place at your workplace, it may be best to speak to a manager about obtaining a lockout tagout system. Inside this kit are plenty of resources to isolate an installation. What we'll be using for circuit breakers are these small circuit breaker lockout keys, and we can also double it up if we wanted to with a padlock. Placing these on a circuit breaker prevents a customer or other worker from accidentally turning the circuit on when it's isolated. Once the lockout is on the circuit breaker, you can see there is no possible way a person can accidentally reliven the circuit. They will have to intentionally remove this first. A secondary way to protect yourself is by doubling up with some form of identification tag or other lockout device. For the next part of the install, we will remove all 4 of these lights. The insides of these lights untwist. Once untwisted, the light bulb will simply unclip. You may need 2 hands at this point to pull these fittings down and remove them from the ceiling jib. Just be careful because there is spring-loaded clips on either side that push down on top of the jib, and they can have a mousetrap effect on your fingers as you remove them. So remove them slowly and keep an eye on those mousetrap clips to make sure that you avoid snapping them on your fingers. As you can see, I've pulled this one down marginally, and the clips I'm talking about are on either side there. An easy method to remove these is to put your thumb against the clips so you can then exert force holding the clips inwards and then release them. Once completely removed, you can see the blemishes I was talking about earlier on the paintwork, and thus it's important to cover the entire piece with the base of the pendant light. Now when we pull on the cable, we should be able to remove the transformer and expose the two cables. Now I'll repeat the same thing for the next 3 lights. Once all of the fittings are removed, the next thing we want to do is remove one of the covers off a fitting and just test that the fitting has no power on it. Before testing with a multimeter, you want to make sure that your leads are intact and that you use the prove test prove method to identify if there's any issues with your meter prior to testing. If you're not familiar with prove test prove method, check out my TikTok. I've got a decent video on there explaining it, which is at the Real Sparky Dave. Place the meter into volts AC and make sure we're testing between the red and black TPS input wires. On our meter it shows 0 volts. So we can be rest assured we've isolated the correct circuit. You want to make sure that you can physically feel a cable connection between each of the fittings, and if you cannot identify that, then it's best practice that you test at each fitting. For the next step, I'm going to remove all of these transformers, so it's just exposed cable hanging out of each hole in the ceiling. Because these cables are solid core 1mm cable, it is always best practice to cut the terminated ends off and start again. Now that all of the transformers have been removed and cut from the cables, it is time to look at fixing options for the new pendants. Fixings provided by the manufacturer are generally less suitable than proper electrician's fixings. Sometimes there are some handy washers and other bits and pieces that you may want to hang on to or use during the install process. For this install, I'll be using the screws that we generally have on hand for installing pendant light fittings. Because the existing light fitting was a recessed unit, you're definitely not going to find any fixing directly above the hole. We're going to have to find a way to add fixing to the ceiling because jib alone is not suitable for hanging multiple pendant lights from. I have some decent offcuts of timber here, and I'm going to jump up in the ceiling and have a look above the light fittings to see what the best option is going to be with adding fixing above them. So now I'm above the light fittings in the ceiling. The easiest thing to do from up here is to place a piece of timber from the farthest batten all the way across the center of the downlights and across the batten after the last downlight, and we'll fix it down to ensure that the timber's not going to move while the pendants are hanging off it. What I'll have to do here is unpin clip some of these cables and just move them out of the road. As you can see now, I've placed some timber down over the downlights. Unfortunately, one piece wasn't long enough for this part, so I've had to use 2, and this timber here only sits marginally on the batten, but there's enough fixing room that I can secure it to that side and that side too without having any lips hanging over that may be a hazard to workers in the roof space in the future. So the next part, I'm going to secure either end into the battens. Now a couple of precautions to take with this. The first precaution is screw size, so you want to use the smallest screw possible. You can see this screw here is long enough to penetrate through the timber and into the batten. If you have a screw that's too long, you may end up going through the batten, out the plasterboard, and create a hole in the customer's ceiling. The other precaution to take is just to be very careful when you're impact driving these screws in, if you're using an impact driver, as the vibrations can cause cracking in paint and plaster work. As I just showed, sometimes screwing a screw in and out several times is a good technique to being careful when screwing them in with the impact driver. Another alternative is having them pre-drilled, but that does add time to the job. So I've now fixed all of the screws in all the way along the timber. I've put screws in every batten to ensure that when I'm screwing screws up for fixing, that they're going into this board here and the board is not flexing upwards or moving about. The next thing I'm going to do is put these cables back underneath the board over the downlight hole that's existing. And then I'm going to make sure I put the insulation back over top of this new board. Now the ceiling is tidied up and we're ready to hop down. Now you can see there's timber nicely above each hole in the ceiling, so we can get some decent fixing in there to hang these lights from. Before hanging these lights, we want to set them to the right height. To get the height right on these lights, the best way to do that is to hold them up to the ceiling and then have the customer determine exactly what height they're happy with. That way you won't get it wrong. It's best to make a coil at the top, so when you set it to a different height, you can then hold on to the cord, and then we know what part of the cord we need to clamp on to the base. In this case, the customer has already gone ahead and placed green tape around the cable, indicating that they want the height set at the center of the green tape through the base. Now we'll disassemble the base so we can pull the cable through from under this fixing plate. Now on here, you can see a wee grub screw. We'll have to loosen that off so we can easily get the cable through. So I've pulled the cable through to where the customer had specified and removed that green tape. Now that the cable has been secured in place by the plastic grub screw, I'll go and get the other 3 fittings out of the boxes and get them set to the same length. To get accurate cable lengths, generally we measure from the base of the cable where it goes through the pendant part of the fitting and all the way back to where the cable goes through the middle part of the base. That length there is 405 millimeters on the tape measure. I'll make the other 3 cable lengths to 405 mils to match the first one. Now the cable length has been adjusted to 405 mil. We're going to need to move the strain relief plastic piece all the way down hard up against the base here. We can leave a small amount of room there for adjustment if we need at the end to pull down slightly or push up slightly. So they all should look like that at the end. Before installing any pendant light fitting, it's always a good habit to test the continuity of the earth connection. What we want to do is put the multimeter in ohms and we'll verify that the leads are in good condition before we start testing. For a pendant light fitting that is not plastic or double insulated, you must test to ensure that the metallic parts are going to be earthed. To do that, we test between the earth on the connector block and the other end onto the metallic part. Now, given that all new fittings are going to be painted, you're going to have to etch a little scratching in a place that's inconspicuous that you're never going to notice once the fitting's installed. As you can see, I've made a tiny little mark on top on the inside there. Put 1 meter lead on that mark and the other one on the earth pin, and we've got 0.0 ohms. That result tells us the earthing is intact and perfectly fine. So we'll test that for each fitting before we install it. Now, another good idea is to put the lamps into the fittings before you install them. They're far easier to screw in when they're on the ground. For the mounting bracket, it's going to be fixed back either side of the jib, straight back into that timber. For this, I'm using some 3-inch screws. These screws are deep enough to go through the timber and firmly hold the bracket against the jib. Now, you want to be careful when screwing the bracket in that we're not putting too much pressure on the jib. It's just a placeholder in place. All of the weight of the fitting is going to be on the timber above. One factor to consider is the orientation of the bracket. Whichever way around we decide to install it, the grub screws on the outside of the base holding it up to the ceiling will be visible. So we want to make sure there's some uniformity to them. If you're unsure which way to mount it, always ask the customer what their preference is. When installing the bracket, we screw one screw in at a time and then we line the other end up. Now you'll see the screw here is in light enough that it is just holding it against the jib, not exerting force onto the plasterboard above. Now what we'll do is get down and make sure this lines up directly in center with the other holes. Sometimes it can be a good idea just to hand tighten the screws right at the end. That way you can ensure you're not going to apply too much pressure to the plasterboard ceiling. Once the base is secured, we'll peel these cables back and strip them off nicely. If you want to see a video of terminating cables, I've got plenty of them, either on TikTok or YouTube at the moment, so go ahead and check those ones out. Once the cable ends are stripped off and twisted together, it's now time to put them in the connector block. You'll see a faint L on this side, earth in the middle, and N on this side. It's important we get the polarity right, especially on these fittings that are Edison screw. You'll also see that the cables are sleeved, and you can double check that behind the sleeving up in here, this cable here is blue and this one here is brown. Brown indicates the active cable and blue indicates the neutral. So I'll screw these in off camera. Once the cables are in correctly and we've double checked the polarity, we can then chuck the cover on and start coiling this black cable up into the ceiling. Given these were existing downlights, we can actually push the excess cable up into the ceiling here so we don't have to cut any length off the factory light fitting. Frequently, when you have more than one cable fit off into the terminal block, the casing doesn't fit 100%. So what I like to do is throw a bit of insulation tape around it a couple of times just to reinforce it to clip in and stay on there. Have the screw caps ready and start pushing the cable up into the ceiling there. A good rule of thumb is to always face the grub screw towards the nearest wall, which is over there in the kitchen. The rest of the room is a living area, so you don't really want to be seeing imperfections. That's the first one done. Now move on to the rest. Once they're all installed, when we're double checking to ensure that they're all even at the same height, the best way to get them perfect, or within 2 millimeters, I'd consider pretty perfect, is to get a tape measure from the bench top and measure up to the base of the light fitting itself. Match that measurement with all 4 lights and they should be able to line up. Now that we're finished and ready to test, we can go ahead and remove our circuit breaker lockout and reliven the circuit. Now it's time to throw the switch on. Always pays to let the customer know that these cords will straighten up in time and look a lot nicer than if they were coiled up in the box. Don't forget to fill out your COC or ESC for the work that you've completed. Cheers for watching everyone. Make sure you subscribe and watch other videos to learn more.